My name is Henry Li, and I will introduce how to bypass all modern modifications of the Microsoft Edge. Let me introduce myself first. I'm a security researcher in Trend Micro CDC 0day.com, and I have 6 years experience in vulnerability analysis, discover, and exploit. I own some boundary from the Microsoft. This is my Twitter and Weibo connector. Okay, this is my partner. My partner name is Jack. Jack has worked in security for 10 years. His focus has been on browser and document vulnerabilities, as well as Mac, Windows, and virtualization vulnerabilities. Jack can't be with us today. He has broken his leg and cannot travel. Okay, this is the agenda about my topic. The first one, I will be introduced how to use the conservative garbage connect bypass address space layout random. Then I will be introduced how to bypass the control flow guard. Okay, I will be according the following 4 parts to introduce how to bypass the ASR. The first, I will introduce the conservative garbage connect weakness. Second, I will be introduce the previous research about this weakness. The second, we will be introduce the Microsoft's improvements about the weakness. The final part, we will be introduce how to overcome Microsoft's improvement and bypass ASR. Okay. First one, I will be introduced what's the garbage connector. There are 2 types of garbage connector. The first one is the conservative garbage connector. The second one is the accurate garbage connector. The accurate garbage connector have the ability to identify all the points in the program at runtime. But the conservative garbage connector doesn't distinguish between data and points in the program at runtime. Okay, we can see the mark and swipe step. Before the mark and swipe began, we can say suppose the object in the memory layout like this. Okay, when we call the connect the garbage in this function, it will be stepped into the market phase. The market phase we do the following thing. They will be scan all the object locked from the GC. If the object is root object reachable, he will be marked this object. If the object is not root object reachable, will be not marked. When the market phase finish, it will step into the sweep phase. The sweep phase will be free the object which is not marked. This is the mark and sweep the process. Okay, I will introduce the conservative garbage connect the weakness. And this is easily GS code segment. The first line I defined a string. The 3 line I created an array. The first line I assigned a noun to the string. The 5 line I will call the connect garbage to do the GC. Okay, we will be see the object in the memory layout. The first, the neat string, the string in the memory represent use the neat string, which have a field called pbuffer. The pbuffer is a pointer to the memory which can save the strings. And the JavaScript, the array is a JavaScript array. And the JavaScript have a field called length. The length is a data, which is int type. The length represents the length of the array. Okay, when we assign the noun to the string, then we call the connect the garbage. Because the string is free, so the GC will free this memory. Okay, let's consider a purchase situation. If the length this is equal to the P buff. Okay, when we do the GC, when step into the mark step, it will be scanned the JavaScript array object when scanned to the length field, because the length is equal to the P buff, and the conservative GC evaluated the length as a point. So there will be markless memory. So when we step into the sweeper phase, because this memory is marked, so this memory will be not free. This is the weakness about the conservative GC. Okay, I will be in this part. I will introduce the previous research. In 2009, a Chinese researcher called Yuan found the conservative GC weakness in Internet Explorer 9. In 2013, a researcher again used this weakness and the time-attacked bypass ASRs on Flash and Firefox. At the same year, a Chinese researcher called Ganis used the this weakness and the time-attacked bypassed ASR on Internet Explorer 11. And in 2015, ZDI researchers used a new attack method called memory protect bypass the ASR on Internet Explorer 11. Okay, I will be detailedly introduce the ZDI's research. ZDI research have do the following. First, they find a side channel attacked surface. The JavaScript out of memory exception can reverse information about the state of the heap. Then they use the memory protector weakness. The last, they will do some memory pressure. Okay. We will be say the memory protector. What is the memory protection? The memory protection is a mitigation used to prevent the use of the free vulnerability in the Internet Explorer. The memory protector algorithm like this. First, when he free an object locked from memory protector, it will not free memory to the operating system. It just adds the memory to a witness. When the witness is greater than 100,000 bytes, then it will do the free algorithm. The free algorithm like this. If the witness memory address is not in current state, it will be free this memory, else it will not free the memory. Okay, ZDI use this to exploit and to bypass AS like this. First, they allocate the memory like a pattern, do the memory pressure. Okay, they make a target memory like at this place. Okay, and this place is in the guest address. Then they put all the guest address into the stack. The second, they free the target memory, because the memory protection algorithm, the memory will not be free to the operating system. They will add the target memory address to the witness. Okay. In this part, the researcher do the following thing. They do some snip, they do some loop. In each loop, they clean the stack. They clean the stack's address, one address. Then there will be node some DL module, which the DL module is equal to the target address VM. If this target address is clear in the stack, then we can know the DL successful in this place because we can guess to this address rate. So when we know the DL at this place, we can successfully get the DL base address in the process. This is the ZDI's method. Okay. When ZDI have reported this vulnerability to the Microsoft do some improvements to prevent this exploit. First, they use memgc replace the memory protection. Second, they reduce some side channel attack surface. Okay, we say the memory protect and memgc. Memory protect, the memory protection do the conservative market sweep GC just on stack regist. The memgc do conservative market sweep GC on heap stack regist. Okay, reduce the side channel attack surface. In the Microsoft Edge, it introduced an abandonment class in rendering engine, and it used the intelligent algorithm for garbage connection. Okay, we will pay attention to abandonment out of memory. When out of memory, when the abandoned out of memory introduced in the Microsoft Edge's render engine, when there is an out of memory, it will throw an out of memory exception. In the JavaScript, we can catch this exception, so we can use this to detect the state of the heap. But when the abandonment out of memory introduced in the engine, when out of memory, it not throw out of memory exception. It just transmit the current process. Okay, we can say the Microsoft do the FS in the Edge HTML. This is the reference to abandonment out of memory in the IDA. We can say there have 3,641 reference to this function. So in the Edge rendering engine, you cannot find something to throw an out of memory exception. Okay, we can do abandonment out of memory like this. We define a function called test, and we create a large strings. Then we create many areas. Then and assign the string to the elements closed attribute. When this statements run, it will allocate a large memory from the operating system. When the operating system have not enough memory, it will be charged the abandonment out of memory. This function will transmit the current process. So this statement will be never run. So in the Edge render engine, you cannot use the out of memory exception to detection the state of the heap. The intelligent algorithm for garbage connect in Microsoft Edge, when call connect garbage function from the JavaScript, the engine decided whether performing garbage connect based on a set of algorithms. So you cannot really time charging GC to connect the garbage. Okay, we can say in the Microsoft Edge, they have this is the host type definition. We can say we pay attention to the host type browser. This host type is equal to 1. Okay, when the host type is the host type browser, and the configures offset 30C is equal, and the host type is equal to 1, not equal to 2, not equal to 3. So this statement will not be run, then we will return a value. So in the browser, and when you call the connect garbage, this function do nothing, just return a value. Let's see the Microsoft's improvements. This improvement can prevent the ZDI's exploring method, but it still uses the conservative mark and sweep GC algorithm management memory, and didn't solve the problem from the root cause. Okay, next part I will be introduce how to overcome the Microsoft's improvements and to bypass the address space layout random. The first, I will be introduce a new side chain attack. The second, attack the surface. The second, I will be introduce a real-time tracking GC method. Then, using this method, we can bypass the ASR. Okay, the new side chain attacks. When we use the following code to allocate the array buff, if processor doesn't have continuous block of memory is larger than the allocate size, it will throw out of memory exception. So use the following code, we can detect the state of the heap. Before we have introduced, the Microsoft have introduced an abandoned out of memory function. But why in this code we can throw out of exception? We can see the error buff's definition in code. Okay. In this part, this will be request allocate. If this allocate, if the memory is not enough, so this will be 0. So it will be throw out of memory exception to the JavaScript code. In the JavaScript code, you can catch this exception. Microsoft just introduced the abandonment out of memory function in the rendering engine, but didn't use this in the Chakra engine. So in the Chakra engine, we can find the new side chain attack surface. Okay. In Chakra engine, the connect garbage function do nothing. When you call it, it won't connect the garbage. But in the Chakra engine, there is a large allocate function. When allocate large memory, if when you allocate the memory by this, it will check the memory will meet the need of user to allocate. If not, it will change mark and sweep garbage connector immediately. Okay, we can see the large allocate definition. This is the this statement. We try to allocate large memory from the operating system. If the result is 0, allocate memory fill. This is out of memory. So it will be immediately do the call this function connect log. This function will immediately do the GC to reset the memory. So use the large allocate, we can define our my connect garbage function. This function can change the GC immediately. The GC memory is a large string, and when use the GC memory the slice function, and it will be allocate large memory from the operating system, because the operating system can't have not enough memory, so it will be go to this part and do the GC. So this function can change the GC immediately. Okay, I will be introduce the exploit step in Internet Explorer 11. And suppose the size of the DL which will be loaded in the process is target VM size. And we will allocate memory in a pattern like the following. First, we allocate the target memory. Allocate a range in which the virtual address space size is the target VM size. And the virtual address space began address, I call it target address, is belong to this and call the memory target memory, and do memory pressure, allocate memory, and make sure there is not a continuous VM space which size is greater than target VM size. Then we will create a point array, save the address which in this and the address mode 1000 is 0. The third step we free the target memory and call the my connect garbage. The fourth step is calculated the target address. When we traverse point array, for each index in the array, we do the following things. The first, we set the point array index to equal. And the second, we will be load the DL to process in try-catch statements. If it throws an exception, continue to the next loop, else load the DL success. We can, and the target address equal to this. The get began address add index plus 1000. Okay, in this part we will be introduced the calculative the target address. First, we will be travel the split point array and then set the split array index to 0. Then call my connect garbage function. Then we will load the deal in try and catch function. If load successful, we can use this reference to connect the target address. If low, we throw out of memory exception, where we go stop into the next loop. Okay, we will introduce like this. The first, we do the memory pressure and create the target memory at this place. Then the every buffer address we point to this. Okay, the second part, we will be use a data reference to target memory. And we will be create a point array. The point array is saved address like this. And then we will, the target address is in the get began address and the end began address. So this array will be have an index which will be saved the target address. Okay. When this statements finish, okay, this part now have two references to the target memory, like this. Okay, the third part will be free the error buff. Because we free the error buff, so the error buff will not point to the target memory. There is just only reference to this target memory. This part we will be calculate the target address. In this part, in this statements, we first we state the support array index is equal to 0. Then we will be do my connect garbage and do this. Okay, we can say that. If the array target is pointing to the target memory, when you attempt to allocate the memory, because there is not enough memory to support the new attack, so it will throw out of memory exception. But when we in this code, when we assign the array target to equal to 0, then there's no reference to this memory. When we do the GC, this memory will be free. So in this time, when we allocate the memory, we will be allocate memory successful. So when the every target is assigned to 0, and then do the GC, this memory will be free. Okay, then we load our the target module. Okay, because this just only this space, only this virtual address space can support the allocate. So we will be allocate the memory at this place. And then we can use this reference to calculate the DL base address. The DL base is get start address at the target index and plus 1000. Okay, we will be do some demo about it. This first demo one is bypass the ASR in the Microsoft Edge. Okay, wait a minute. Okay, this is the Windows 10 version when I report the vulnerability to the Microsoft. This is the Edge's version when I report this vulnerability. Okay, we will run this. This we spend need time to collect the address. Okay, we will be check whether this address is right. So we can say the NIC address is equal to the start about the model's start address. Okay, we will see the bypass along demo in the Windows 10 on the Internet Explorer 11. This is the Windows 10 version. And this is the Internet Explorer 11 version. Okay, we will run this in the Internet Explorer. Allow this run. Okay, this will be spend need time to can collect the target address. Okay, we can see here find the WMP module's base address like this. We will be check it. Okay, we can say we successfully nick the WMP module's base address. Okay, we can say the GC, the conservative the GC's weakness we can use this weakness to bypass the ASR in the private. And this weakness affect all the Microsoft browser use the consecutive GC contains the Microsoft Edge in the Windows 10. Consider Internet Explorer 8, 9, 10, 11 on all the Windows platform. Okay, this part I will be introduce how to bypass the control flow guard. When we began to introduce this, let's introduce why we need the CFG bypass vulnerability. The left part, the left picture is an exploit about the use after free vulnerability. We put the stack pivot address at the fake vegetable's write process. When the core instruction run, it will be run over the stack pivot, then run over the rope gauges, then run over shellcode. The The right picture is the situation when the CFG introduced in the Windows 10. So when the core instruction run, it will first call the CFG check to check the stack pivot address where the CFG valid. Because the stack pivot address is officially not a begun address of a function, the CFG check will be failed. Then it will be prevented our shellcode to run. Even if you have the arbitrary read-write vulnerability, you also find the vulnerability to bypass the CFG to exploit your shellcode. So the CFG bypass vulnerability is very important to your exploit. Okay. This method I called use eSIM bypass CFG. The vulnerability type is called sensitive API out of context. And this vulnerability in the eSIM module. Okay, we see what's the eSIM. This is the eSIM in the Microsoft Edge. This is the eSIM architecture in the Microsoft Edge. Okay, when the table process wanted to do something, wanted to call the frame process do something, it will be called use the Edge eSIMs. The Edge eSIM will be hook match functions. In this hook function, they can do some check, and maybe they can translate the table process call to the frame process. Okay. The eSIMs have the following working hooking functions. The following functions are all safety validated, like watch protect, watch locked, and the map view of the. Okay. And in this part, I will be use the watch protect as a demo to explain how to exploit this vulnerability to bypass the control flow guard. Okay. The watch protect has four parameters. So we must to find a function have the same count parameters like the watch protect. Luckily, we find a CDOM text load object. This object have a function called substring date. This function have four parameters like the watch protect. Okay, I will be demo how to exploit this. Use the first. We create a CDOM text load object, and second, we will fake the CDOM text loader's watch table. Then we will write the watch parameter to the substring data in the watch table's offset. Then we call the substring data using this as parameters. Because the substring data is overwritten by the watch protect. So when you call the substring data function, it will go to the watch protect function. When this function finish, we got a page. The page is memory protection is page execute read write, and all the page is address, and all the address in this page is CFG valid. So we can copy our shellcode to this page. Our shellcode is page execute read, and the shellcode's start address is CFG valid this. So using this method, we can easily to bypass the CFG and the DEP. Okay, I want to thank the ZDI research, Abdullah, Simon, and Brian. They give a good attack surface in the ASLR. I want to special thanks to Yang and Gaulis. Anyone have a question?